What does it take to make a small 6-inch long miniature vessel? Well, depending on your appetite for details and perfection, it could be a lot. In this 3-part series, I'll be demonstrating step by step how I made a small 26 scale meter long N-scale barge for my grain facility in Wrightsville Port. In episode 1, today I'll tell you the background and how I conceptualized the build, how I did research to find the appropriate prototypes, how I curved every single component from stock styrene supply, and finally how I scratch built the model absolutely ground up. My grain facility is not a typical one that you see in a model railroad. Here, the barges or other small vessels bring the grain, which is then offloaded using a small pneumatic unloader, a relatively modern tech in the 60s, the period which the layout is set in. A conveyor belt then delivers the grain to a step conveyor that raises the material to a dizzying height at a steep angle. The grain then makes a U-turn on a conventional conveyor belt again, and then it's delivered to the silos. To ship the grain through train, conveyor belts concealed underneath the silos and bucket conveyors in the elevator building are used to raise the grain to the appropriate height, and then deliver it to the covered grain hoppers in the loading shed. Once loaded, the train takes the shipment out. The facility is complete with all the details for a few years now. The only remaining piece is the barge, and that's what this project is all about. The moment you say barge, people imagine 200 to 300 feet long barges stacked one after the other pushed by a huge tug. However, mine is a small port, and clearly a 300 feet barge will never be able to enter this quay. So I'll be building a small barge. I found a bunch of prototypes in my online research, real barges operated by real companies today that are in the ballpark of 25 meters in length. So I picked a traditional small tri-cargo barge suitable for the scene as a prototype. The links to some of these sites are mentioned in the description below. The prototype barge I chose is 26.5 meter long with a 6.4 meter beam. The dimensions translate to 165 mm and 40 mm respectively in N scale. I also considered a ballpark of 1 scale meter of freeboard since this will be a loaded vessel. Now, I'll not be following the prototype barge absolutely as is. The barge I have in mind is an old barge even back in the 60s, so something from the post-World War II era perhaps. My scene also requires the hold to be covered since the material is grain. I decided to go for 2 separate holds covered by old wooden hatch covers. What I have in mind is old, gritty and dirty, something so commonplace, something so unimpressive that if you spot one in real life, you wouldn't look twice. The first step is to transfer the dimensions onto the styrene sheet. I took a piece of 1 mm thick styrene sheet and used the cutting mat grid to square out 2 adjacent edges. Then I started drawing the plan of all the surfaces starting from the deck. At this point, I still hadn't decided how I want to represent the hold and what level of details I want to show, so just to keep my options open, I decided to go for cutting out the hold. For the bottom and the side pieces, I used projection of the top view. Notice that for the bottom piece, the depth of the 2 sides, that is 1 mm each, was subtracted from the overall width so that everything fits square with each other. The barge will also be a rect barge, not a box one. You can identify the type from the drawings of the sides. I also decided on a subtle detail at this point. First, notice that the forehatch is slightly smaller than the one in the aft. Second, as I was imagining the scene, I decided to show that the grain is already in the process of unloading in the forehatch, while crew is still working on removing the hatch covers from the other one. These 2 factors would mean that the bow of the barge will be slightly raised than the stern. If you notice the drawings of the side, you will see that at first I drew a temporary waterline that is parallel to the deck. Then I increased the height of the freeboard at the bow by 3 mm compared to the stern. That is little over 1 scale foot. The final waterline marked in bold is now not parallel to the deck, as you can see in the drawing. Once I was satisfied with the drawings, I started to cut out the pieces. Cutting 1 mm styrene is pretty easy. Cut till about halfway through and then gently fold and wrap along the cutting line. The pieces will snap easily. Care needs to be taken though while cutting the lines at an angle. For the hold, I'd simply cut the rectangles and their diagonals, and then gently pry and break the inner pieces. As you can see, I did make an error in judgment as to how deep my cut was in one of the corners. This caused a clear snap and broke the piece when I started removing those triangular pieces. However, given the lines are straight and the shape is intact, I simply carried on, knowing that the broken piece can be glued pretty easily. I followed the same methods to cut out all the corners as per the drawing. Once the cutting is over, it's time to file everything square. I used a carpenter's saw file to file the edges and the corners. I found these files to be extremely reliable and sharp to get perfect inside corners. Starting with the building process, first step was to join the sides to the base. Now the hull has a decreasing width at the stern, a rather sharp bend right after the second hatch. In order to bend the sides, first I scribed the styrene with my hobby knife and then took the V end of the carpenter's file to make a tiny V groove. Then I carefully bent the styrene along the line. I joined them temporarily using tape to see how they fit. Then I had measured and cut the internal frame supports for bow, stern, and between the two hatches. I had to carefully sand them to ensure that they fit properly and sit square to the side and the bottom. It's time to start gluing. Enter methyl ethyl ketone, or commonly known as MEK or butanone, key ingredient in many commercial plastic cement products. This half-a-liter bottle of MEK costed me about 600 Indian rupees, that's about $9 US, far cheaper than any commercial products. The material is highly evaporative in room temperature, so I transferred a small amount in an airtight glass container for my use. To thicken the liquid, I put a few scrap pieces of styrene in the jar. The styrene will melt and thicken the solution, and sometimes the molten styrene can act as putty. I started by gluing the cross supports to the base. First, I put a matching number on each piece against their respective slots just to ensure I glue the right support at the right place. To glue the supports, I just held the piece in place and took one old brush to apply MEK on both sides. Kept holding it for a few additional seconds while the fluid melts the plastic and eventually welds the joint. Once the cross supports are glued, I started with the sides. First, I taped the starboard side in place and then applied MEK on all the joints. Since the side is taped to the base, I could easily move it while applying the liquid without risking any misalignment. Notice that I'm using a piece of baking paper to save the top surface of the cutting mat from MEK stains. Once the starboard side cured, I did the same to fix the port side. Coming to the deck, I started at the bow. Notice that this is a raked bow, so the foredeck is raised at an angle with respect to the rest of the deck. Remember the piece that I broke while cutting out the hatch from the deck? It's time to attach that to the sides. For this one, I'm adding the MEK on the surface first, along with some molten styrene. All I have to do then is just press the foredeck in place while the styrene is still in molten state, then give one final brushing of MEK. The rest of the deck was one single piece, and it was easily welded to the hull and the foredeck using the same methods. This is a good time to start cleaning up the model. First, I scraped away any obvious protrusion using my hobby knife. Then I took a piece of 400 grit sandpaper to quickly flatten any remaining rough edges. Next, I used the 800 grit for fine sanding. Areas that required a smooth curve rather than a sharp joint line, like the reducing width of the hull towards the stern, needed some special sanding. I rotated the model while sanding, thus creating a curvature along the sanded surface. This helped in hiding the joints and made them rounded as well. The last two pieces of the hull were the rake bow pieces. I'd simply cut pieces of styrene in appropriate sizes and joined them to the side and the underside of the deck. This completed the base structural elements, the hull till the waterline and the deck. Next thing to build is the coaming, and I started with the forehatch. First, I held a rectangular styrene sheet along the edge of the deck inside the hatch. Then I drew a line along the top of the deck on it. Next, I drew a parallel line 4 mm apart from the first line and cut the piece along the second line. Remember that the water line is not parallel to the deck and the vessel is raised towards the bow. This method ensures that the coaming sits square with the deck and not the water line. For the sake of simplicity, I decided to go for simple square brackets for the coaming. I took a 1.2 mm by 0.8 mm styrene strip to make the brackets. Since I needed quite a few 4 mm long pieces, I decided to make myself a quick jig. I took a small piece of scrap styrene and cut a 4 mm deep groove. I filed it square and glued it to another scrap piece of styrene. Then I placed the styrene strip in the groove and cut it flush at the mouth of the groove to get perfect 4 mm long strips. I had to be careful to always keep my knife perpendicular to ensure I have a square cut for all the pieces. Next, I took some MEK on the lid of the container to start gluing the brackets to the coaming. Now here is the trick to pick up pieces of styrene without using a pair of tweezers. Take the sharp pointy end of your hobby knife and gently tap on the styrene piece, and you should be able to pick it up without a fuss. Dip one surface in the solvent and quickly place it on the model you're building. Use the finger to hold the piece for a few seconds and there you go, it's permanently welded. Care should be taken though that you don't press the knife too hard on the styrene piece, that might just cut it in half. Once the brackets are fixed to the coaming, it's time to glue the coaming to the barge. First, I put some additional supports at the bottom along the length so that the coaming sits perpendicular to the deck. Then it's just a matter of welding them in place. Once the joint is secured, I give it a test fit at the quay just to ensure that I'm on the right track and all measurements have worked out properly. The coaming across the beam required to be handled differently. Remember that I am making a covered barge and I decided to go for old-timey wooden hatch covers. This required a central beam that is higher than the coaming on the side so that there is a slant in the cover which helps quicker displacement of water from top of the hatch. After I marked out the height and width of the piece that aligns with the side coamings, I drew an obtuse isosceles triangle on top of that. At the vertex of the triangle, I'll have to make a groove for the central beam to sit. After a bit of filing and sanding, I got a perfect fit. Continued the process for the other coaming as well. To make the center beam, I picked up a 2 mm and a 1.5 mm styrene strip. I needed a beam with tiny groove on both sides for the wooden hatch covers to sit. First, I cut the 2 mm strip to the appropriate length of the beam. Then I cut two 1.5 mm strips of the same length and sandwiched the 2 mm strip in between them to create a 0.5 mm groove on top. Next, I'd cut a groove at the vertex of the two triangular coamings so that the beam can sit properly. Everything was then test fitted to check for accuracy. Before fixing the coamings, I fixed the brackets on them. The process was mostly the same, except that this time I kept the strips a little longer while fixing them and then cut them flush at the top edge of the coaming. Now, it's just a matter of fixing these in their respective places and then attach the center beam. This is how the barge and the forehatch looked at this point. I continued with some fine cleaning with my hobby knife wherever required before moving on to the next step. It's time to do some fine finishing, and I needed some microfiles to handle all the nooks and crannies. From my collection of sandpapers, first I selected 3 grades, 800, 1200 and 2500 grit. Then I took a few toothpicks and cut them from the middle at an angle. Next, I'd cut some small rectangular pieces from the emery papers, approximately 4mm by 3mm each. I took a drop of super glue on the severed end of the toothpicks and simply picked up the small pieces of sandpaper. The super glue cured in a few seconds, and I had a very handy and useful microfile. I made a full set of 2 files for each type and wrote their grades on the toothpick. Filing with these microfiles was not only fun, but immensely effective. With these files, I could achieve as much precision as I wanted and wherever I wanted. I continued to sand any irregularities, however, I did not go for absolute perfection. This is an old barge, and a little bit of imperfection on its surface is going to go a long way to achieve that effect. To make the hatch rest bar, I took 1.5mm styrene strips and cut them according to the sides that I will be fixing them on. The math is this: the thickness of the styrene used for coaming is 1mm, whereas that of the brackets is 0.8mm. If I fix these strips flush with the top of the brackets, I'd get a fine 0.3mm groove on the inside of the coamings to fit the hatch covers. Time to get the microfiles into action again. I continued filing in the nooks and corners to achieve as much fine finish as required. I used my hobby knife for some fine shaping as well. For the coaming of the other hold, I basically continued with the same process. However, to ensure that the brackets are distributed at the same distance from each other as it is in the first hold, I marked their position in the second coaming simply by holding it against the first one and marking the position of the brackets. Then, it's just about following the same steps and taking the build towards the finish line. Once the building process was done, I did one final round of sanding and filing and finished preparing the surface. The construction of the barge is almost complete. By this time, I've already made a small hatch door to access the maintenance areas of the hull. So the only remaining details are the bitts and the bollards. I decided to go for only one pair of bitts at the bow, and rest all would be bollards. For the bitts, I decided to go for a 1.5mm diameter post with a 2mm top. For the post, I chose the rod from a pack of styrene rods and tubes assortments by Evergreen Models. For the top, however, there was no 2mm rod in the package, so I had to make do with a tube of same diameter. First, I used a 1.5mm drill and a pin vise to expand the inner diameter of the tube so that the 1.5mm tube can be inserted. Then I'd cut about 1mm thick hollow disc from the tube and a 5mm long piece of rod. I inserted the disc on top of the rod flush to the post and glued it using super glue. Once the bits are made, I measured their position on the deck, basically the center spot at the foredeck. I drilled the holes, inserted the posts, and glued them in. For the bollards, first I had cut thin discs from a 1.5mm rod and 4mm posts from a 1mm rod. Then I dipped the discs in MEK and pressed them on top of the posts. I needed 10 bollards, but in the production line approach, I made them fairly quickly. Next, I measured the positions of the bollards on the deck, making sure that they are symmetrical. I took a pin and punched the markers. Then I took a 1mm drill and the pin vise, drilled holes in the designated spots. Once all the holes are drilled, I inserted about 1mm of the posts into the holes to place the bollards. A small drop of MEK in each secured them in position. This is how the barge looks till now. I haven't fixed the small hatch cover yet because I need to paint it first. However, here is how it looks when I place the small hatch door in its designated place. Now that the barge is built, it's time to start painting and weathering. However, that is for episode 2. Thank you for watching, and I really hope that this demonstration is helpful for you in your miniature making. And if you haven't done it already, subscribe and hit that bell icon so that you can catch the very first glimpse of episode 2, where I'll be showing how I painted and weathered this model in extreme detail. Till then, happy modeling!